Okay, so here we are on a real staircase, and as you can see, on this step, for example, it would be very difficult to set the pendulum test up. We could do something on this step, but we would have to move to a smaller slider to be able to make a useful measurement on this nosing. And we have recently developed a smaller slider for just that purpose. To enable us to get some information about this step then, we can use a complementary measurement, which is one of surface micro roughness, and this is a typical meter that will allow us to make that measurement. So I can make some measurements on this step, where I can also use my pendulum, and then I can make some measurements simply of the roughness on this step. And if I'm getting similar roughness values on both nosings, then I can be reasonably confident that they're going to perform in the same way. The other thing that I can do with the roughness meter is move along and make measurements in different points across the nosing, and I can then begin to understand the way that that surface might be wearing. And if it's wearing, it will change, and if it changes, it will certainly change in terms of slip resistance. So this is quite a useful complementary measurement that can be used with the pendulum to give us more information about how the stair, and particularly the nosing, is likely to behave. Here's a picture of a couple of different flights of stairs, and you can see we've got a material there that's been chosen because people will think it will offer some protection against slipping accidents, and clearly it hasn't worked, and they've had to then retrofit some nosing materials. Picture on the left, you can see the area of wear right on the edge of the nosing. So this is why the nosing has to go right to the edge of the stair, and ideally in this situation be wrapped round the stair. And you can see also how that little roughness meter that I showed you could be used to monitor the changes across that surface. Similarly, on this stair here, a nosing has had to be fitted, and this time it's a much more aggressive material. It is wrapped round, and it's probably going to mean that the staircase is effective in terms of protecting people against slipping accidents. This is a picture of a flight of stairs in a public building, and you can see here that without the nosing it's very, very difficult for the pedestrian to be able to discern the edge of the nosing, and that is surely going to lead to an increased risk of an accident occurring on this staircase. That will be compounded if you've got people with poor eyesight or wearing varifocal glasses. Really not a good idea. Here's an example where a nosing has been fitted to a step, but really this strip here is in the wrong place. It needs to be brought forward where it can have the most impact. And really, it's not necessary to have these luminous yellow colours on the edge of nosings. They just need to be contrasting, they need to be visible, they need to warn people that there's a hazard ahead. This is a ramp test then. This is a test that we have some confidence in as well. It tells us something about how surfaces behave. What Rob's doing here is walking in a very controlled way in a piece of footwear that has got a standard rubber sole on, and it's the same standard rubber that you saw earlier on the pendulum test. We've got a reference surface here which is a plain steel, and we've got water running down that surface. Rob continues to walk and then changes the ramp angle incrementally at about 1 degree intervals until eventually we get the slip. The angle at which the slip occurs allows us to work out the friction between the surface and this standard soled rubber shoe. Okay, so you need to think about stair nosings, and if you do decide that they're appropriate, think about where you position them, think about the lighting so that people can see them, think about the shape of them. But if it's going to be in a foreseeably contaminated situation, maybe by an entrance, maybe around a production area, then you really do need to know how they're going to perform in terms of slip resistance. So the thing you need to do is test them.